Hi everyone, welcome to the very first video of this new series on coordinate geometry. Today we are starting with one of the most important and honestly one of the most beautiful topics, circles. Now I know what usually happens. You pick up a reference book and suddenly you're lost in pages and pages of theorems, lemmas and results. It feels like you're drowning in formulas before you have even understood the basics. And by the time you get to the good problems, half of your energy is already gone. That's exactly why I am making this series. My goal is to give you a crisp, no nonsense learning path. We'll start from the ground up, basic equations, simple concepts, and gradually build all the way up to the advanced level problems that have actually appeared in JEE Mains and Advanced, step by step without wasting time. Think of it like this: instead of spending weeks combing through everything, I'll give you exactly what you need to crack questions fast and confidently in the exam hall. And here is the best part: this isn't about just circles. If this series gets a good response, I'll keep making similar playlists on other crucial topics in coordinate geometry and beyond, so that you'll eventually have a complete, focused, exam ready library right here. So, if you have ever felt overwhelmed by too much theory or struggle to connect concepts to actual problem solving, this series is for you. Stay with me till the end because by the time we are done, you'll see circles not as a scary chapter but as one of the strongest weapons for you in your JEE. Let's get started. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur, and I welcome you all to the first episode of this series on circles. So let's get started. So what do we have here? So first, let's start with the definition of circle. So what is a circle? A circle is a locus of a point which moves in a plane such that its distance from the fixed point in a plane is always constant. So there are two important things here. The first thing is the fixed point and the second thing is the distance being constant. So you have a fixed point, let us say h comma k, and then you collect all the points which are at a fixed distance r from this particular point. So this is one point which will be at a distance r, and here you'll get another point which will be at a distance r, and here you'll get another, here you'll get another, here you'll get another. So like that you will be getting infinite number of points, and when you join all these points together, the shape that forms is called as a circle. It is as simple as that. So the circle is a collection of all points which are at a fixed distance from a fixed point, and that fixed point is called as center. This h comma k is the center and r is your radius of the circle, and the diameter of the circle is defined as the straight line which passes through the center of the circle, and the length of the diameter is 2r, and the diameter is denoted by small d. So now let us see how to write the equation of the circle. In your 11th standard, you must have done this chapter called locus. Alright. So we have to find the locus of this particular point which is at a fixed distance from the fixed point which is your center. So this point on the locus, let that point be px comma y. So now we know that the distance between these 2 points is r. So just apply the distance formula. Then you will get square root of x minus h whole square plus square root of y minus k whole square is equals to r. Alright. When you square it on both sides, you get x minus h whole square plus y minus k whole square is equals to r square. Here your center is h comma k and your radius is r. This is the center and this is the radius. So this is how you write the equation of a circle. When the center of the circle and the radius of the circle is given. Now let us proceed. So this is the first thing we have learned here. Let's proceed. So this is the generic equation of the circle. So this is simply x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now, if this type of equation is given, how do we find the center and radius of the circle? So let us do exactly that. So let us write the equation like this: x square plus 2gx. Let us add g square to this and subtract g square plus, so we have taken these two terms. Now let's take these two terms, y square plus 2fy. Let us add f square and subtract f square. Now the left out term is c. So this is the equation that we have. So this is simply x plus g whole square, and this is y plus f whole square. And if you take the other terms to the right hand side, here you'll get g square plus f square minus c. Now compare this equation with this particular equation that we have derived. Then we will get h is equals to minus g, k is equals to minus f, and r is equals to square root of g square plus f square minus c. So if this equation is given, so your h comma k center will be minus g comma minus f. If this equation is given, your center will be minus g comma minus f, and your radius will be square root of g square plus f square minus c. All right. So you have two ways of writing the equation of a circle. The first way, this sort of equation is used when the center of the circle and radius of the circle is known, and this is the generic equation of the circle. And when this particular equation is given, you can find the center like this and the radius by using this particular expression that we have derived. And what if the center is origin and radius is r? Just put h is equal to 0 in this equation and k is equal to 0. So you will get x square plus y square is equals to r square. So this is the equation of the circle with center as origin and radius r. So these are the three equations of the circle that you have to remember. All right, and I have shown you how these are derived as well. So let us move ahead. Now, how do you find the equation of the circle passing through three given points? Let us say three different points are given to you: x1, y1, x2, y2, and x3, y3. All right. Now a circle is passing through these 3 points. All right. So you are asked to find the equation of this particular circle. How do you do that? Here in this episode, I would like to present two approaches of doing this. There might be many other approaches, but I would like to present these two approaches here. So you have 3 points, and assume that the equation of the circle is this: x square plus y square plus 2gx plus 2fy plus c is equal to 0. Since x1, y1 lies on this circle, you can substitute that into this particular equation, and when you do that, you will get this. Similarly, you can substitute x2, y2 and you will get this. Similarly, you can substitute x3, y3 here, and then you will get this. So if you observe, these three are three equations that you got with the variables g, f, and c. So you have three equations and three variables. You can solve these equations to get g, f, and c. And once you get the values of g, f, and c, you can plug those values into this particular equation, and then you will be getting the equation of your circle. All right. So let us move ahead with the second approach. Now, second approach is, so you have these 3 points on the circle, these green points on the circle. Now using these 3 points, you can form a triangle. Correct? So the circle that we have passes through the vertices of this triangle. So this circle will be the circumcircle of the triangle. Alright. And the center of circumcircle, and the center of the circle will be the circumcenter of this triangle. So center of this circle is simply circumcenter of triangle. Alright. Now if you find the circumcenter, if you are able to find the circumcenter, so you can use this equation of the circle, x minus h whole square plus y minus k whole square is equals to r square. H will be the x coordinate of the circumcenter, k will be the y coordinate of the circumcenter, and r will be the circumradius, which you can find out by calculating the distance between the circumcenter and any one vertex of the triangle. Alright. So now how do you find the circumcenter? So let us say you have a triangle here. Alright. A, B, C. What is the definition of circumcenter? Circumcenter is the point of concurrency of perpendicular bisectors. So let us say this is the perpendicular bisector for this side. So these two lengths will be equal. And this is the perpendicular bisector for this side. So these two lengths will be equal. So this is the midpoint of BC. So B is given to you and C is given to you. You can calculate the midpoint. Alright. So you have a point here. And you need the slope to find the equation of this line. So you can calculate the slope of BC. Since this is the perpendicular bisector, once you get the slope of BC, you can calculate the perpendicular slope. Now you have slope and point on this line. You can find the equation of this perpendicular bisector. Similarly, you can find the equation of this perpendicular bisector, and when you solve both the equations, you will get the coordinates of circumcenter. And once you get the coordinates of circumcenter, you find the distance between the circumcenter and any one vertex. Then you will be getting the value of your circumradius. Alright. So now let us solve a problem using these two approaches. So now you are given the coordinates given to you are 0, 0, 3, 0 and 4, 0. Alright, you have to find the circumcenter. Sorry, the equation of the circle passing through these 3 points. The first approach is to assume that the equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equals to 0. So this point lies on this, so substitute. This will be 0, 0, 0, 0 plus c is equal to 0. So this implies c is equals to 0. Next, this also lies on this circle, so it will be 9 plus 0 plus 6g plus 0 plus c is equal to 0, and we know that c is 0, so put c is equal to 0 here. So g will be minus 3 by 2. Similarly, substitute this point. Then you'll get 0 plus 16 plus 0 plus 8f plus c is 0. So this will be 0. So f is simply minus 2. So you got g, f and c. So substitute back into the equation. X square plus y square plus g is minus 3 by 2. So 2g is simply minus 3. So this is minus 3x. So f is minus 2, 2f is minus 8, y plus c is 0. So this is the equation of the circle. Alright. Now let us use the second approach to solve this. So your 0, 0 lies somewhere here and 3, 0 lies somewhere here. Sorry, this is not 4, 0. This is 0, 4. While substituting, I did the same thing. So I substituted 0 for x and 4 for y. Alright. So this is 0, 4. Now you have to find the circumcenter. Okay, first let us find the equation of this perpendicular bisector. Alright. So for that we have to find this point. This point is simply the midpoint of AB. Alright. So which will be 3 by 2, 0. And the slope of AB is 0 minus 0 by 3 minus 0. So this is 0. So therefore, slope of AB is 0. So AB is parallel to x-axis. So this line will be parallel to y-axis. So therefore, equation will be x is equal to k. So now since this point lies on this perpendicular bisector, so you can put 3 by 2 is equal to k. This implies k is equal to 3 by 2. So x is equal to 3 by 2 is the equation of this perpendicular bisector. Now let us find the equation of this particular perpendicular bisector. You can find the equation of any two perpendicular bisector. Let us find the equation of this perpendicular bisector. Alright. So for that we have to find this point. So this is the midpoint. That will be 3 by 2 comma 4 by 2, which is simply 2. Now we have to find the slope. So slope of BC is 4 minus 0 by 0 minus 3. 4 minus 0 by, so that is simply minus 4 by 3. So slope of perpendicular bisector is 3 upon 4, since they are both perpendicular. M1 into M2 is equals to minus 1. So slope and point, we know both of them. So you can use point slope form. Y minus y1, which is 2, is equal to M. M is slope of perpendicular. X minus x1, 3 by 2. Alright. So this is simply 8y minus 16 is equals to 6x minus 9. So 6x minus 8y plus 7 is equals to 0. So this is the equation of another perpendicular bisector. So now this is one perpendicular bisector, this is one perpendicular bisector. So solve both of them. Put x is equal to 3 by 2 in the second equation. So you'll get 6 into 3 by 2 minus 8y plus 7 is equal to 0. So this will be 2 1s, 2 3s, 9. 9 plus 7 is 16. 16 is equals to 8y. This implies y is equal to 2. Alright. So x is 3 by 2 and y is 2. So this is the circumcenter. So now what is the equation of the circle? Circumcenter, x minus 3 by 2 whole square plus y minus 2 whole square is equal to r square. Now we have to find out r. So 3 by 2 and 2 are the coordinates of circumcenter. So it lies somewhere here. So now we have to find the distance between that and any one vertex. So let us consider origin, since origin is one of the vertices. So 3 by 2 comma 2 and origin. So that will be 3 by 2 whole square plus 2 square. So this is r square. Now if you simplify this, you will end up getting the same equation. So this is how you use these two approaches to find out the equation of the circle passing through 3 points. So let us move ahead now. The next topic is like, how do you find out the equation of the circle when the endpoints of the diameter is given? So this is one endpoint of the diameter and this is another endpoint of the diameter that is given to you. Now you have to find the equation of the circle. So how do you do it? So let us consider one random point on the circle px comma y. Now let us denote this as A and this as B and this as P. Now let's form a triangle like this, APB. Since this is the diameter, the upper part is one semicircle and the lower part of the circle is another semicircle. So the triangle APB lies in the semicircle and the angle in a semicircle is 90 degrees. I hope you remember this from your high school. Let the slope of AP be M1 and slope of PB be M2. Since these are perpendicular, M1 into M2 should be is equals to minus 1. So what is M1? M1 is y minus y1 upon x minus x1 multiplied by M2 is y minus y2 upon x minus x2 is equals to minus 1. So when you cross multiply, you will get y minus y1 into y minus y2 is equals to minus of x minus x1 into x minus x2. So send all the terms to one side. You'll get x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So when the endpoints of the diameter are given, this is the equation of the circle. Alright, and you have derived it by considering a simple fact that angle in a semicircle is 90 degrees, and then we used the concept of perpendicular slopes. Let us move ahead. So next thing is parametric form of a circle. So what is a parametric form? Parametric form is something where we represent the x coordinate and y coordinate on the locus in terms of some parameters. Alright. So let us say, once we solve this, you will understand it better. So let us say this is the circle, this is x axis, and this is your y axis. Alright. And this is the circle. Let us say the center of the circle be h comma k, and this is a random point considered on the circle denoted by px comma y. Alright. And let us say the fixed radius is r. Alright. So the center is given to you and radius is also given to you. Now you have to find out, let us introduce a parameter theta. The parameter that I was talking about was theta. Theta is angle made by this random point with x-axis. This line is parallel to x-axis. So this point makes angle theta with x-axis. Now let us find out this particular length. If you apply trigonometric ratios, this will be r cos theta and this length will be r sin theta. Just apply sin theta and cos theta in this right angle triangle and you'll be able to find out those lengths. Now what is x? So to get x, so this is x. Alright. So to get x, first we have to travel till here and then we have to go here. So this distance is simply the x coordinate of the center. This is simply h and this is r cos theta. Similarly, what is y? This is y. To travel till y, we have to first go till here, and this is simply k, y coordinate of the center. So this distance is k and this is simply r sin theta. We have derived it here. So x is h plus r cos theta and y is k plus r sin theta. X is h plus r cos theta and y is k plus r sin theta. So h and k are given to us and the fixed radius is also given to us. So we are expressing each of the coordinates in terms of theta, and theta is the parameter that we have introduced here. So this is the parametric form of the circle with center h comma k. If the center is origin, it is simply r cos theta and r sin theta, because your h and k will become 0 in this case. Alright, let us go ahead. Now the position of a point with respect to a circle. You have a circle, the equation of the circle is given and you are asked to find out whether a given point lies inside the circle or on the circle or outside the circle. Alright. So let us try this with, okay fine. So next thing, so let us try this. So let us say the equation of the circle, s of x comma y is equals to 0. So let's say this is the equation of the circle and s of x comma y is simply your x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now a point is given to you and you have to verify whether this point lies inside the circle, outside the circle or on the circle. So let us say that point is x1 y1. If s of x1 y1, that means you have to put the value coordinates x1 y1 into this expression. if s of x1 y1 is greater than 0, the point lies outside the circle. The point x1 y1 lies outside the circle. If s of x1 y1 less than 0, the point lies inside the circle. If s of x1 y1 is equals to 0, the point lies on the circle. So now let us say you have to find out whether these points 2 comma 0, 0 comma 0, 1 by root 2 comma 1 by root 2 lies on this circle. X square plus y square is equals to 1 lies on the circle or inside the circle or outside the circle. Now first we have to write the circle in this form. So x square plus y square minus 1 is equal to 0. So in this case your s of xy is equal to x square plus y square minus 1. So this is a circle with center 0. So here it is x minus 0 whole square. So center is 0 here. You remember x square plus y square is equal to r square is a circle with center 0, I mean origin, and the radius is 1. So 2 comma 0 lies somewhere here, 0 comma 0 is the origin, and 1 by root 2 comma 1 by root 2 lies on the circle. Now let us see according to the theory whether that is correct or not. So first let us substitute 2 comma 0. 2 comma 0. So this is 4 minus 1, that is equal to 3, which is positive. So this means that it lies outside the circle. If you find out s of 0 comma 0, it is simply minus 1, which is negative. So that means it lies inside the circle. Try to substitute this and check. You'll get s of 1 by root 2 comma 1 by root 2 as 0. That means that it lies on the circle. Alright. So now you understood how to check the position of a point with respect to circle. Let us move ahead. So far we have discussed these things. So how do you find the equation of the circle when the center of the circle is given and radius of the circle is given? X minus h whole square plus y minus k whole square is equals to r square. And the generic equation of the circle, x square plus y square plus 2gx plus 2fy plus c is equals to 0. The center is minus g comma minus f and the radius is square root of g square plus f square minus c. And the equation of the circle with center 0, 0. So that is simply x square plus y square is equals to r square. And the parametric form of the circle, which is x is equal to h plus r cos theta, y is equal to k plus r sin theta, where h comma k is the center of your circle and r is the radius. Circle passing through 3 points. The first approach and the second approach. First approach is where you blindly substitute the coordinates into the equation of the circle and you get 3 equations, solve those 3 equations to get G, F and C. And the second approach is to find the circumcenter and then circumradius and then substitute in x minus h whole square plus y minus k whole square is equals to r square. And the fourth thing is position of a point with respect to circle. Alright. S of xy greater than 0, the point lies outside the circle, less than 0 inside the circle is equals to 0 on the circle. Tangent equation. So this we have not discussed. I will show you a problem. I will not discuss this thing as a concept. We will solve a problem based on whatever we have learned today, and from there you will understand the tangent equation of the circle. Alright. So let us jump right in and solve the question. So this is the question that we have. Find the condition in A, M and C if y is equal to mx plus c is a tangent to the circle. So you have a circle like this and there is a tangent drawn to this circle. So let us say this is the tangent. Let us say this is the tangent and this is the point of tangency. This is the point of tangency and this is the tangent. Now the equation of the circle is given. X square plus y square is equal to a square. So this is a circle with center 0 comma 0 and radius a. Alright, this is a and radius is always perpendicular to the tangent. This we know from our high school mathematics. And the equation of this tangent is also given. So y is equal to mx plus c. Now we have to find out the condition a between a, m and c so that this y is equal to mx plus c is a tangent to this. Now what can be done? So y is equal to mx plus c. So if you consider this particular point, at this particular point, both the circle and the tangent has same x and y coordinates. Therefore, I will substitute this equation into this equation. So mx plus c whole square plus x square. So I substituted y is equal to mx plus c is equal to a square. And here x is the x coordinate of this particular tangent. Alright. So let us expand this. This is simply m square x square plus c square plus 2mcx plus x square is equals to a square. Let us bring all the terms to one side. So this will be m square plus 1 x square plus 2mcx plus c square minus a square is equals to 0. Now, since x is the x coordinate of this particular point of tangency, there is only one. This is a quadratic equation in x, and there should be only one solution because there is only one point of tangency. One point cannot have two different x coordinates. So this quadratic equation should have only one solution. So therefore, discriminant should be equals to 0. Discriminant is b square minus 4ac equal to 0. Your b is 2mc whole square minus 4. A is m square plus 1 and c is c square minus a square. So this is 0. So 4m square c square is equal to 4 multiplied by m square c square minus m square a square plus c square minus a square. So this 4 and this 4 gets cancelled. So this is m square c square is equals to m square c square minus m square a square plus c square minus a square. So this and this gets cancelled. So let us bring all the negative terms to one side and positive terms to other side. So this is a square into m square plus 1 is equal to c square. So this is the condition between a, m and c for y is equal to mx plus c to be a tangent to this particular circle. So this is a very famous concept. So you have to remember this actually. I presented it as a problem to you guys, but this should be remembered. So for y is equal to mx plus c to be the tangent to the circle x square plus y square is equal to a square, your c should satisfy the condition that c square is equals to a square multiplied by m square plus 1. Now let us not leave the question here. So we'll do further analysis on this. So c square is equal to a square plus m square. A square into m square plus 1. So that means c is equals to plus or minus a into square root of m square plus 1. So now, since this is a single tangent, c should have only one value. But why are we getting two values for c here, plus and minus? That is because, so you have the slope m as a parameter here. So a circle can have, so let us say, so this is the diameter of the circle. If you draw one more tangent at this particular point, so this will be perpendicular to the radius. So this particular tangent and this particular tangent, these two will be parallel to each other. Parallel tangents will have same slope, correct? So therefore, when you put for each value of m, for each value of slope, you will get two different tangents, one with the positive sign for c and the other with the negative sign for c. All right. So yeah, this is the condition that it should satisfy. And for a particular value of m, you will have two tangents for a circle, one with a positive value of c and another with a negative value of c. To eliminate these two choices and decide on any one tangent, some extra information has to be given in the question, such as the point, some point lying on some tangent or something else. So with this, we come to the end of this video. So this was the first episode of the concept circles. We will have many more episodes coming up where I'll be explaining the complete theory, not the entire theory which is present in the books, just simply whatever is needed to solve questions till JEE Advanced level. And once the theory part is done, we will be solving some good questions, and These series of episodes will be posted as a playlist on my YouTube channel. So if you have not subscribed to the channel, do subscribe for the amazing content that we are doing here, and share it with your friends. And if you are liking the videos that I'm making, leave a like on the videos. And if you have any queries on whatever we have discussed in this video or any generic doubt, feel free to reach out to me in the comment section. Thank you very much. We'll meet you in the next episode.